Hello students, today we will discuss about the interference of light. The interference of light is a wave optics phenomena in which we consider that light is made up of waves, and according to Huygens principle, the source of light emits light in the form of wavefronts. And what is wavefront here? That I would like to tell you. The wavefront is the locus of all the points, all those points of all waves emitted by the source which are in phase. That means these are the points where all maxima or crests or troughs or other points are in phase. For example, we assume that there is a source of light which is emitting one wave of light like this. It is electromagnetic transverse waves this way, and this is taken as crest, and this point is taken as trough. Crest and trough. So from a point, countless waves will be emitted in all the three dimensions, and each wave will have such kind of crests and troughs. And wavefront will be a wavefront at a point will be locus of all these or these points where all the waves will have the crests and troughs. They will be in phase, and generally we show this crest as a solid line like this, and this trough as a dotted line like this. So it means that if plane wavefront is traveling along positive x-axis, then it may be divided into a solid line and dotted line, solid line and dotted line, solid line and dotted line. It shows that all the waves traveling towards this side, they have this crest on the same point, trough on the same point, crest on the same point, trough on the same point. So instead of showing this wave, what we can do is we can show that this source S is emitting wave, which can be denoted by this kind of solid line and this kind of dotted line. Solid, dotted, solid, dotted, and so on. So according to Huygens principle, the light travels in the form of waves, which can be represented in the form of these wavefronts. And if the source of light is extended source, that means if we take this as a source, extended source of light, which is not a point source, then wavefronts will be plane. But if the light source is point source, let us say, then you will find spherical concentric spheres, then wavefronts will be concentric, which shows that waves are radially expanding, radially traveling outward, and each wave has its crest and trough on the same point as I have explained there. So spherical wavefronts are denoted by this, plane wavefronts are denoted by these planes, and every source which is at large distance or infinite distance provide parallel wavefront at the point of observation. So according to Huygens principle, source of light emitting wavefronts, And if two waves of same wavelength and same phase meet at a certain point of the in the direction of its traveling, then bands of brightness and darkness are produced, and such bands under certain conditions when formed are called interference pattern. Now before going into detail, I will show you some of the interference patterns so that in later on during the study of interference we could understand what is the meaning of bright points and dark points. So let me show you the some real uh, images of interference patterns. So here are the two patterns I have taken. One is with the pinkish light here, other is with the green light, and you can find this brightness and brightness is separated by some dark points. So this darkness in the pattern is called a dark fringe, and this bright point is known as bright fringe. Similarly here also you can find this is a central maximum, central brightness, then this is another brightness, but in between we have darkness. Here also we have darkness, this is bright point. So such kind of pattern, these are called interference pattern of light, and these are produced when two waves from special kind of sources of light mix together or superimpose, and they produce on the screen such kind of pattern, which is interference pattern. Now the special sources which produce it, they are called coherent sources of light. They are, we generally say these are coherent sources. And let me just show you what is that coherent source. I am talking about coherent sources. Coherent sources mean the two sources of light, one source, another source, two sources of light which emit the light of same wavelength and same phase. And such patterns are visible only when the waves have the same amplitude also. Now such coherent sources can be obtained by using such uh, light source, but this light source should have a monochromatic source which is only one wavelength, and it should have a fine slit, and when light emits in the form of wavefront, and this spherical wavefront will strike with these two slits, then according to Huygens principle, these two sources will also become another sources of light, and new wavefronts will be generated from here. And these wavefronts will keep on expanding like this, they will keep on expanding, and on expansion you will find that these thick lines and dotted lines will meet, and on certain distance, at certain distance on the screen, you will find this kind of brightness, then darkness, then again brightness, then again darkness, and again brightness. So such image or such pattern here and here you will obtain on the screen, and These patterns are obtained when the waves from this source and waves from this source, they will meet at this point, and this superposition of the waves will decide whether it will be point like this bright or point like this dark. If two waves, mean first wave has suppose this position and second wave have this position, then the resultant will be a amplitude double of it. So you will get a maxima, that is such brightness. And if one wave portion will be like this and other wave portion will be like this, then you won't get any light here, it will be darkness. No amplitude means darkness. So therefore this brightness and dark patterns will be obtained on the screen. So coherent sources can be obtained by many techniques, but this double slit method was used by Young first of all. So it is called Young's double slit method of obtaining interference pattern. So I will discuss about the Young's double slit experiment in the next video.